Hi there and welcome again to Cambridge Advanced Level Mathematics here, the channel that prepares students for their advanced level mathematics examinations. In our previous video, we talked about complex numbers, and we actually discovered that if we had an equation of the form x squared plus 3x plus 4 is equal to 0, we could solve it in the normal way, the quadratic formula, and say, okay, our x is equal to b is 3, so it is minus 3 plus or minus, let's do it slowly, plus or minus the root of b squared, which is 3, so that gives us a 9 here, minus 4 multiplied by AC. A is 1, and our C is 4. And this is under the square root sign, and everything here is divided by 2A, which is 2 times 1 because our A is 1. So let's simplify that. This gives us x is equal to minus 3 plus or minus the square root of 9 here. This is 4 times 4, which is 16. 9 minus 16 is minus 7. So it's minus the square root of 7, of course, divided by 2. We saw also that we can write this as minus 3 plus or minus the square root of 7 multiplied by the square root of minus 1, all divided by 2. But we discovered that the square root of minus 1 is not a real number. It is an imaginary number, and that imaginary number is denoted by the symbol I. So we can write the solutions here. There are two, because there's a plus and a minus there. Our two solutions will be minus 3 plus or minus the root of 7I divided by 2, which gives us the solution. The first one is minus 3 plus the root of 7I divided by 2, or minus 3 minus the root of 7I divided by 2. So these are the two solutions of the equation x squared plus 3x plus 4 is equal to 0. These two numbers are called complex numbers. Look at the structure of them. There is an imaginary part here and a real part there. An imaginary part, this one here, and a real part there. And we noted also that whenever we run into the problem of roots which are not real for a quadratic equation, those roots always come in complex conjugates, because this here is the complex conjugate of this one. Look at the difference. It's a minus 3 plus this. Then this one is a minus 3 minus that. So this one is the complex conjugate of this one and vice versa. Okay, so now in today's video, we would like to go a little further now with complex numbers and discuss the algebra of complex numbers, if you like. In other words, how do you add two complex numbers together? How do you subtract them? How do you multiply complex numbers together? How do you divide complex numbers together? So, supposing we have two complex numbers, and let's call them Z1 and Z2. Normally, complex numbers are denoted by letters such as Z or W or U, but of course, anybody is free to choose any letter they want to represent a complex number, provided you define your notation. So let's suppose we have a complex number Z1, which is equal to 3 plus 4i. Okay, the real part or imaginary part. And another complex number here, Z2, which is equal to 1 minus 2i. So there are our two complex numbers. Supposing we wanted to add Z1 to Z2. So we have Z1 plus Z2 My set is not clear there. What we do, we add the real parts together and the imaginary parts together. So we say this will be 3, the real part here is 3, the real part there is 1, so plus 1. Then we take our I, put our bracket there, the real part here is 4, and the imaginary part here is minus 2. Then we simplify, 3 plus 1 is equal to 4. 4 minus 2 is equal to 2i. That is Z1 plus Z2. Subtraction is a similar process. Z1 minus Z2. So Z1 minus Z2 would be equal to, we take again the real parts. So we have Z1, for Z1, the real part is 3. For Z2, the real part is 1. So it's 3 minus 1. And then we come over here, the imaginary part, Z1, it's 4 here, minus, what is Z2 imaginary part? It's minus 2, so it becomes 4 minus 2, which of course is 4, becomes 4 plus 2. Simplifying, we have 3 minus 2 is equal to 2, 3 minus 1, sorry, and then here 4 plus 2, then it becomes 6i. So it's 2 plus 6i. That's Z1 minus Z2. What about multiplication of complex numbers? Multiplication of complex numbers, it's almost similar to the process of multiplying one algebraic expression with the other, except that you have to take care of the i's when you multiply them together. So here we want Z1 multiplied by Z2. That gives us 3 plus 4i multiplied by 1 minus 2i. Okay? 3 times 1 is equal to 3. 3 times minus 2i is minus 6i. 4i times 1 is plus 4i. 4i times minus 2i. Now we must first of all deal with our real part. 4 times minus 2 is minus 8. And I times I is minus 1. Okay, so let's just put this thing here. I squared is always equal to minus 1. We have to know that. So here we have a 4 times minus 2 giving us a minus 8. Then combining that with the minus 1 that comes from the I multiplying itself, we have a minus 8 times minus 1, which gives us a plus 8 here. So combining everything together, we have 3 plus 8, which is 11, minus 6 plus 4i, which is minus 2i. So that's your Z1 times Z2. Okay? Let's go on to division. Division of two complex numbers. It's a little bit different from all the other operations we've done so far. So supposing we want our Z1 divided by Z2. Sorry, Z2 there. So we have 3 plus 4i divided by 1 minus 2i. What we do with with division is that we multiply the denominator, the whole complex number, the numerator and the denominator, by the complex conjugates of the denominator. What is the complex conjugate of the denominator? It is 1 plus 2i. So let's go ahead and do that. So this becomes 3 plus 4i for our numerator there. So now we must multiply it by the complex conjugate of that, which is 1 plus 2i. Then we come down here, 1 minus 2i. But we must also multiply it by the complex conjugate, which is 1 plus 2i. You will see what happens when we do this. when we get to the end of the process, which is very interesting. So let's deal with the top first of all. 3 times 1 is equal to 3. 3 times 2i is plus 6i. 4i times 1 is plus 4i. 4i times 2i, this is 4 times 2, which is 8. Then I times I is minus 1, so it becomes minus 8 here. Okay? Down here, what happens? 1 times 1 is 1. 1 times 2i is plus 2i. Minus 2i times 1 is minus 2i. Minus 2i times 2i, so minus 2 times 2 is minus 4. Minus 4 multiplied by the I times I, which is a minus 1, it becomes minus 4 times minus 1, which is equal to plus 4. Okay, plus 4. Simplify. 3 minus 8 is equal to minus 5. I hope I'm not blocking your view. 6i plus 4i gives me a 10i. Down here, 1 plus 4 is equal to 5. 2i minus 2i is nothing. So you see, the denominator has come to be real. That's what happens every time you multiply a complex number by its complex conjugate. The result is a real number. So that is division of Z1 by Z2. But let me just say a little bit more about our I squared here, the powers of I. Remember, we said I squared is equal to minus 1. So what about I cubed? I cubed would be equal to I squared multiplied by I, which is equal to minus 1 times I, which is minus I. What about I to the power 4? I to the power 4 is equal to I squared multiplied by I squared, which is equal to minus 1 times minus 1, which is equal to plus 1. I to the power 5, so it's I to the power 5 is equal to I squared times I squared times I. Well, these two gave us a plus 1, so combined with that, it just gives us an I. The most important thing to remember is to know that I squared is minus 1. From there, you can manipulate the powers. Doesn't matter how many times you try to multiply I, start with your I squared is equal to minus 1, and from there you can proceed and find whether it's I or it's minus 1 or it's a plus 1. That will do for today, but in our next video, we're going to be discussing the modulus of a complex number, and we will also discuss the argument of a complex number, in other words, the angle it makes with the positive x-axis, and we will also discuss the Argand diagram. But remember, of course, this is a channel that takes past examination questions and solves it, or tries to solve it for that matter. So we will do this before we go back to our normal procedure where we pull out an examination question and solve it. So after this, of course, we will look for a past examination question on complex numbers, and then we see what we can do with it now that we will have gained all the necessary theory behind complex numbers. Till we see you again. Bye-bye. Have a good time.